Right now we're going to learn about type 1 binary compounds. The first thing you should know about type 1 is that it's only between nonmetals and metals. So I'm going to give you an example. Potassium and fluoride are both a binary compound when they are joined, because fluoride has an oxidation state of -1 and potassium has an oxidation state of +1. So when you join them, they reach 0. So the compound would be Kf. Now there are moments when you won't get an exact 0. For example, magnesium fluoride. Magnesium is +2 and fluoride is -1. So you would have to have 2 fluoride to get a -2, so that it would equal 0. It's important to know that first you need to put the metal. Sorry, like in magnesium fluoride, you put magnesium first, and in potassium fluoride, you put potassium first.
Hi, now we're going to explain how type 2 binary compounds work. A type 2 binary compound is a compound between transition metals and nonmetals. To write the formula, you have to write the oxidation state of transition metals in Roman numbers. An example of a type 2 binary compound is here. Copper 2 oxide. This is the oxidation state. So it would be Cu +2 and the charge of oxygen, which is -2. Since +2 and -2 cancels out, then the answer will be CuO. A more complex example would be iron with an oxidation state of 3 and fluoride. That will be written like this: Fe with an oxidation state of +3 and F with an oxidation state of -1. To cancel it out, you will need 3 fluoride elements. So the answer would be FeF3.
So for type 3 compounds are composed by 2 nonmetals, and these are written with math prefixes. For example, mono equals 1, di equals 2, tri equals 3, tetra equals 4, penta equals 5, hexa equals 6, hepta 7, octa 8, nona 9, and deca 10. So an example of a problem is SO2, and so you know that S is sulfur and O is oxygen, so you just put sulfur dioxide. Since because they're telling you that it has 2, so because it has 2 molecules. For the next one, and see that in sulfur, I know that it has 1, but I didn't put mono because in the first one, if it's just 1, you should not put mono. For in the second, so here they're giving you C and O, and since even though that C has 1 molecule, you put carbon, and then this one that is oxygen monoxide, since it has 1 mono. Then so this is an example where they give you the written expression: the nitrogen monoxide. If you look here, the nitrogen is 2 nitrogen, so N2, And monoxide equals mono 1, and oxide is oxygen, so O, N2O. And when writing from the written expression to the equation, you should put the one that is closest to being a metal. Even though these two are non-metals, the closest to being a metal is the one that you write the first.
And I am going to be explaining oxidation state in the periodic table. This is how you can tell the oxidation state just by looking at one of the elements. For example, here on the right side, we see that the first column, which are the noble gases, are perfect. This column is -1, this one is -2, this one is -3. So, if you want to know the oxidation state of one of the elements on these three columns, for example, oxygen, the oxidation state of oxygen would be -2 given to its position on the periodic table. And on this side, it would be the same but in reverse. Here it would be +1, here it would be +2, and on this one it would be +3. So if you were wanting to get the oxidation state from one of those three columns, an element, like calcium, the oxidation state would be +2, +2.
In order to determine a compound's bond, it is important to compare the element's position in the periodic table. For instance, when two elements like lithium and oxygen are located far from each other in the periodic table, the bond tends to be, or is generally considered to be, ionic, since the difference between their electronegativities is very high. However, when two atoms of nitrogen and carbon bond with each other, since they are near each other in the periodic table, the difference in their electronegativities tends to be lower. So the bond will be either polar covalent or covalent.
The bond which conducts greater electricity is ionic because the substances dissolve better.
So the question is lithium chloride powder mixed with copper 3 oxide and dinitrogen monoxide blended with dicarbon monochloride, that is gas, producing acidotes with solid lithium chloride blended with copper along with oxygen and nitrogen combined with liquid fluorine and chlorine, that is gas. And here lithium chloride is type 1. Lithium chloride is type 1. Copper 3 oxide is type 2. And dinitrogen monoxide is type 3.
Now Felipe will tell me the elements and I'll say their oxidation state.
The elements are lithium,
1,
chlorium,
-1.
copper,
It's a transition metal.
oxygen,
3,
nitrogen,
-3. Oxygen is -2, nitrogen is -3, hydrogen is 1, fluorine is -1, and carbon is 4.
Thanks for watching.
This is the formula for the.
This is the equation in chemical. And here you can see the equation without the spectra ions. They are in the solution but not involved in the reaction. They look the same in both sides of the equation.